3, 2, 1. Hi folks, we're back here at Saugus Station in Newhall, California for an update to our other video on hand signals in the daytime. Now obviously you can see it's getting dark out here, so we're going to show how things were done at night. That adds a whole new dimension to the railroad.
Between the three of us, you're looking at 120 years of railroad experience combined.
And we all started working with lantern signals when we hired out. We didn't have radios. We all had to work with the lanterns and pay attention to everything going on because there was no lollygagging around with the lanterns. You had to keep an eye on everybody on the crew. And if it meant passing signals, which means people were in different locations, that's how it worked. Now the lanterns were developed, well, of course, at the beginning of railroad with the fuel oil lanterns, and then they went to batteries around 1928. And we'll show you a few of the lanterns right now.
Initial lanterns, were an open flame. This was called a tall globe. It's a little bit heavier, and your light is literally a kerosene lit flame. Later on, they went to what was called the short globe. It's a little bit squatter, it's lighter. One of the interesting things that some of the old heads told me about using these is if you do a kick sign, you had to be really careful because a kick sign involved a pinwheel action like this, and the flame could go out. And so you had to be really careful. The flame went out, and you got an engine kicking, but you can't get them stopped. So as you can see, they were designed to stay lit. And all three of us pretty much hired out with the aluminum conger lantern, and you had a lantern battery inside with the top cap, and you had a selection of two lights. This concave was like a reflector mirror, and it acted like a spotlight, so if you need to light up the right-of-way ahead of you, it formed a beam. The other light down here doesn't have that concave. That's your signal lantern, and that's what the engineer, that's what you want to give signals with. You give signals with this spotlight, the engineer's going to get kind of pissed off.
You have a lot of mad guys.
Because it's like throwing a high beam in your eyes. Then if you work passenger service, but passenger men use this, it's really compact, still has two lights, and the hasp would fold and it could go into the coat pocket.
You took 2D batteries.
Yeah, these didn't obviously use a lantern battery. And then, 70s?
Oh, 80s? A little later than that, 80s? I think, yeah. 80s, 90s.
We got our first all plastic lanterns. Pretty much the same design with the concave area in here with a reflector mirror.
And it still has the regular bulbs.
Yeah, the regular bulbs. And then you get into the LED era. These are being used today.
Yeah, these are
this one got
really bright lights, and they can be turned on spot or signal.
Yeah.
And the other nifty little thing on this item is they have 3 magnets on them, so they can literally stick on anything metal. So if you need a work light, or maybe even for a caboose or whatever, just to take a shove, you could stick it right on there, not have to hold on to it all the time. Because it was important as a brakeman to keep your light with you at all times.
You ever set the lantern on the ground or side and then go do work? Because the engineers are looking at the light, not at you. So if he sees the light, he figures that's where you're at, and he might say, okay, he's in the clear. And you could have somebody get somebody on your crew given a signal, seeing the other light and thinking everybody's in the clear. The worst thing you want to do is set your light down and go in between equipment to work. You take your light with you. That way the engineer sees you're out of view, and he has to account for you before he's going to move. And then, of course, the signal of last resort is what's commonly in the outside world called the flare. but on the railroad we call these fusees.
And these would come in handy. Like, we would oftentimes cut in helper engines 60 cars away with one of these, no radios. And so you'd be given, even in the daytime, you start using night signals. So you'd have like a backup, and then an easy, and then that'll do with this flare, or fusee as they call them.
Yeah.
These only last 10 minutes, other than highway flares last 20 minutes though.
Yeah. But
these were a last resort.
Another real handy use of the fusee before radios, and when I say before radios, you know, when we started, there was always a radio on the caboose and on the engine, but trainmen didn't have their own packs that carry around with them, and so if the brakeman had to, if you coupled to a long cut of cars and the brakeman had to walk back maybe a mile, and you wouldn't be able to see any kind of signal even during the day, you know, you'd have a briefing ahead of time, and he'd say, when I throw this fusee up in the air, that means I'm at the end, the brakes are off, and you can start pulling out, or it can be a brake test at the air or a high ball, and he'd light this thing and just throw it up as high as he can, and you'd see it. And then you'd whistle off to acknowledge that you saw it, and then, you know, proceed with whatever the move was.
The other reason why a lot of trainmen wore bibs or coveralls, there's a pocket for everything.
Yeah.
That fusee goes right in that pocket just like that.
Most of my career was as a locomotive engineer, so I'm going to take my place up in the cab, and then what we're going to do is create some scenarios similar to what would go on if we were switching cars, or I'd be taking signals from the ground crew.
And Bill will take his place here on the footboard because Mike can't even see past the hood of this engine, the boiler. And I'm going to be going down the track here ways, so Bill will be passing signals from me to him to Mike.
I'm on the locomotive, obviously stationary, but we're going to simulate as if I am moving and performing a switch move. We're going to move down a track as if we're going to, Mike is going to bring me to a coupling or a joint, as we say, on a cut of cars. And what's different, one of the main differences between hand signals during the day and lantern signals at night is that hand signals are in relationship to the person giving the signal. Come to me, go away from me, are hand signals. The lantern is in relationship to the locomotive in which way it's facing. If you give it a head sign, that means the locomotive is to move forward. And that could mean if the locomotive is pointing in, you know, against the point of the front of the locomotive is against the cars, that means ahead, you're going to shove the cars. And then the backup sign with the lantern means that the locomotive is to operate in reverse.
Now we're going to start out with an A head. So I'm going to give an A head to my brakeman, and obviously the engine would start moving.
Billy's giving me a startup signal. He wants me to move, so we're going to start moving in to make a joint on a cut of cars.
This would be a 5-car sign.
Okay, just got a 5-car sign.
Then we have a 3-car sign.
Okay, there's 3 cars. So now I'm, going to start easing him up a little bit, and he's trying to judge too as he's looking down the track.
Then a 2-car sign.
2 cars. And the easier I go, it makes it easier for him. You don't want to just run right in on a coupling.
A 1-car sign.
Okay, 1 car. Now I'm really starting to slow down.
And an easy sign. That means slow down.
Okay, he's giving me an easy sign, and the speed of that signal is how easy he wants me to go. The slower he goes, the slower I go.
And the easy sign goes right into a stop.
And then right into a coupling. He just gave me a stop sign.
And that's how basically the relay does, because the engineer right now cannot see me. now I'm back on the caboose. Mike can see me, and we're going to go through a few signals here, and he's going to tell you what he sees up there, and we're just going to go over them real quick. And the first one we're going to do is just everybody should know this one. It's called a stop signal. Just 90 degrees to the track. Stop.
Okay, Mike has just given me a stop signal, and that right now we're stopped anyway, so it's mainly just a demonstration.
Okay, this is called an emergency stop. I'm going to do it real fast. That means stop right now.
Okay, what he's giving me now is like a panic stop sign. We call it a washout. And that's, you stop as hard as you can, putting the train in emergency. There's something wrong. And he just wants an instant stop.
Next signal would be an A head. So straight up and down towards Mike. A head.
Okay, now I'm getting an 8-head sign, so I'm going to start pulling because it's, again, in relationship to the signal, we're going to start pulling in this direction. So it's kind of awkward because I have to turn around and look ahead, but keep watching him for signals.
Okay, the next signal is to back up. So I want him to back up my way. So I'll be doing a circle. A circle means back up.
Okay, now Mike's giving me a backup signal, so we're just going to start moving in reverse with the locomotive, and he'll basically, using lantern signals, signal me as far as I'm going to go. It could be a very long distance or just a few cars.
Okay, the next signal will be set the brakes. That means to set the brakes in the train or the engine. So that's just straight across. Set the brakes.
Okay, Mike is giving me, it's a set the brakes signal, but at least on the Southern Pacific, on the LA division, that would also be a signal if he was going to go in between the cars, like to couple the air hoses or turn an angle cock or something. But the meaning's the same. He set the brakes. He doesn't want me moving because he's in a situation where if I moved, he could get injured or killed.
Okay, the next signal would be a pin. That would be like a short little backup to get the pin on the train, because you have to have the couplers together to separate them. So this is a real quick.
Okay, Mike's just asked for a pin, which is in relationship to the coupling. He wants to uncouple the cars, and if the slack is stretched, the uncoupling lever will not operate. The slack has to be in to where he can get the pin to where I could pull away.
The next signal is called a kick sign. That means you want to get them going real fast, like if you're going to let cars roll by themselves. So kick is a real fast backup, basically. So,
okay, my favorite signal. Mike just gave me a kick sign, and that's basically shove as hard as I can, as fast as I can, because what we're doing is a gravity switch. We're going to shove this car, and I'm just going to keep the throttle wide open until he gives me a stop sign. And when he stops, he's uncoupling the car, and what we uncouple from is going to just continue on its own.
okay, the next signal will be a kick and a stop simultaneously. So kick them and then stop into a stop.
Okay, he just gave me a quick kick and stop, and that's usually something where you just need to give it just a quick hit and then stop, because the relationship to the yard. You don't want to kick a car too hard to where it runs out, the other end of the track or out the other end of the yard. Experienced trainmen know the relationship of a yard or where you're switching an industrial spur, and just what it takes to get a car to move where he wants it to move on its own, without it becoming a dangerous move.
This next signal will be something I really probably give to another trainman on the crew, but just an like cut off. Just cut off.
Okay, the signal Mike gave me is mainly in relationship. He would give that signal to another crewman. It's an uncouple signal. Let's say he was taking a shove to a joint, and then the head brakeman was with the engine. When he gives the uncouple sign, that means he wants the head brakeman to uncouple the engine, or maybe the first car or two. But that is a signal between two trainmen that he wants them to uncouple, and the other trainman knows the move, and so he knows to go ahead and uncouple, and then that other crewman will take over signaling me.
you can also do a lot of counting with your lantern. So I give a 5, 10, 15, 16, back up.
Okay, now Mike is acting like a herder. Herder is a switchman in the yard that he's like a switch tender. He takes care of all the switching movements for multiple jobs that are working in the yard, and he controls the lead. And you need to get his signal before you come out of the track. You don't just come out on your own. So if you're in, he gave me a 16 sign and then a backup. So that means I'm in track 16, which I already know. So he's calling out the track number and then telling me to go ahead and come out by giving me a backup signal. And then I would respond to him with a whistle signal.
Okay, we're going to have one more signal. It'd be like release the brakes. So just that would mean to release the brakes.
Okay, Mike just gave me a release the brake sign. That would be in relationship if he was conducting an air brake test. We talked about the set the brakes. Well, here's, now he's wanting me to release the brakes, and then I would go ahead and release the brakes. And then depending on the situation, he would either give me a movement signal, or if it's a situation where he has to actually inspect that all the brakes would release, he would start inspecting the train for the release with a brake test.
One of the big thing on the railroads is always rolling by somebody else's train. So if a train came by you, you're required to get out on the ground and watch it go by. So you had to acknowledge their train and tell them everything was okay. So you would just give something simple like a highball, and then he would acknowledge my signal, and then you'd walk away and be done with it. But that would just tell him everything's okay with his train, highball. If there was something wrong with his train that I saw, I would give him a stop sign. And then he would immediately either get to his radio and tell the engineer to stop his train if something was wrong. Well, thank you for watching our video. We hope you learned something about night signals. It's a pretty interesting way of railroading without radios. It's almost unimaginable to anybody working today. We had a lot of fun out here tonight. We're all kind of tired, and we'll just kind of roll on down the main line in this caboose, even though it's stopped.
So let's look at no, we don't have enough pressure on the gauge yet to do an air test. Gosh, it's getting awfully late, but we're on the cushions now, so we're off the ground, and it's going to be a better night now.
We're all kind of tired, but it's a good kind of tired.